મારું નામ ડૉક્ટર અતુલ પટેલ છે. હું એલડી એન્જિનિયરિંગ કોલેજમાં મેથેમેટિક્સનો આસિસ્ટન્ટ પ્રોફેસર છું અને છેલ્લા 13 વર્ષથી ત્યાં મેથેમેટિક્સ ભણાવું છું. લાસ્ટ લેક્ચરની અંદર આપણે પાવર સિરીઝ, એનાલિટિક ફંક્શન, રેગ્યુલર પોઈન્ટ, ઓર્ડિનરી પોઈન્ટ, સિંગ્યુલર પોઈન્ટ, રેગ્યુલર સિંગ્યુલર પોઈન્ટ અને એના ક્લાસિફિકેશનની વાત કરી. હવે આ લેક્ચરની અંદર આપણે સોલ્યુશન ઓફ ડિફરન્શિયલ ઇક્વેશન બાય પાવર સિરીઝ મેથડ જોઈશું. સોલ્વ dy by dx minus y equal to 0 by power series method. Okay, solve dy by dx minus y equal to 0 by power series method. હવે પાવર સિરીઝ મેથડથી આપણે આ સમ સોલ્વ કરીએ. તો પહેલાં કમ્પેર કરીએ અને સ્ટાન્ડર્ડ ફોર્મ સાથે તો ડી સ્ક્વેર વાય બાય ડી એક્સ સ્ક્વેર પ્લસ p of x dy by dx plus q of x y equal to 0. So this implies in this આમાં p of x થશે આપણું 1 and q of x થશે આપણું -1 and both are analytic at x is equal to 0. Therefore, 0 is an ordinary point. એટલે અહીંયા 0 ordinary point થયું અને આપણે જો 0 ordinary point હોય so we consider y is equal to sigma k is equal to 0 to infinity a k x raised to the power k, that is equal to a0 plus a1x plus a2x square and so on, right, as a solution of given differential equation. એટલે આને આપણે સોલ્યુશન તરીકે લઈશું. નાઉ અવર એમ ઇઝ ટુ ફાઇન્ડ આઉટ વોટ ઇઝ a0, a1, a2 એન્ડ વોટ ઇઝ કોરિલેશન બિટવીન ધીસ કોઓપ્શન. ઓકે, સો ફર્સ્ટ આપણે આ કન્સિડર કર્યું કે આ આનું સોલ્યુશન છે. નાઉ કન્સિડર, સો વી ટેક y ઇઝ ઇક્વલ ટુ સિગ્મા k is equal to 0 to infinity a k x raised to the power k. So this implies my dy by dx a thase sigma k is equal to 1 to infinity k into a k x raised to k minus 1, right. Now put this value in differential equation. તો આપણું ડિફરન્શિયલ ઇક્વેશન હતું dy by dx minus y equal to 0. તો આ બંને વેલ્યુ આપણે આમાં મૂકીએ y અને dy by dx ની, તો આપણને મળશે સિગ્મા k is equal to 1 to infinity k into a k x raised to k minus 1, right, minus sigma k is equal to 0 to infinity a k x raised to power k. This is equal to 0. Student, this equation is known as a identity. આને આપણે એક આઇડેન્ટિટી ઇક્વેશન તરીકે લઈએ છીએ, right. Now 0 means what? This 0 means 0 plus 0x plus 0x square plus 0x cube and so on. So the coefficient on right hand side ના coefficient જેટલા બી થશે એ 0 થશે. હવે આપણે આની અંદર this is આ બહુ સૌથી ઇમ્પોર્ટન્ટ સ્ટેપ છે કે અહીંયા x raised to power k minus 1 છે, અહીંયા x raised to power k છે, અહીંયા સિગ્મા છે. તો આની અંદર આપણે પાવર સરખો કરવો પડશે અને પાવર સરખો કરવા માટેની એક ટેકનિક છે. તો હાઉ ટુ ચેન્જ ધ ઇન્ડેક્સ? સો ચેન્જ ઇન્ડેક્સ ઇન ફર્સ્ટ ટર્મ. હું પહેલા ટર્મની અંદર ખાલી ઇન્ડેક્સ ચેન્જ કરું છું. તો અહીંયા પાવર જે છે એક્સનો એ k -1 છે અને મારે ત્યાં પાવર જોઈએ છે k. તો હું શું કરીશ, ટેક k -1 that is equal to k, અને આના બરાબર હું k લઉં છું, ખાલી ઇન્ડેક્સ ચેન્જ કરું છું, રાઈટ. તો મને અહીંયા શું મળશે, તો આ ઇક્વેશન થશે પહેલા ટર્મની અંદર, જો k -1 is equal to k, so k is equal to 1 લઉં, so this k is 0. તો જે નવો k છે મારો એ 0 થી સ્ટાર્ટ થશે અને ઇન્ફિનિટી થશે. નાઉ k is equal to શું થશે, તો આ 1 ને આ બાજુ લઈ જાઓ તો એ k + 1 થશે, સો ધીસ ઇઝ k + 1, રાઈટ. એ k એટલે એ k + 1, રાઈટ, અને x રેઝ ટુ પાવર k, કારણ કે k -1 ઇઝ ઇક્વલ ટુ k લીધો. સ્ટુડન્ટ્સ, આ સ્ટેપ છે એ સૌથી ઇમ્પોર્ટન્ટ સ્ટેપ છે. તમારે આ સ્કિલ ડેવલપ કરવી પડશે. દરેક ક્વેશ્ચનની અંદર આપણે આ જ રીતના ચેન્જ ઇન્ડેક્સ કરીશું, રાઈટ. તો આ ચેન્જ ઇન્ડેક્સ કરી, અહીંયા x રેઝ ટુ પાવર k -1 હતું, મેં અહીંયા x રેઝ ટુ પાવર k લાવી દીધો અને આ લઈ દીધો. આ ટર્મને આપણે કશું નથી કરતા, એટીટી જ રાખીએ છીએ. તો માઇનસ સિગ્મા k ઇઝ ઇક્વલ ટુ 0 ટુ ઇન્ફિનિટી a k x રેઝ ટુ પાવર k, ધીસ ઇઝ ઇક્વલ ટુ 0. આ મારું થઈ ગયું આઈડેન્ટિટી ઇક્વેશન. હવે આને આપણે નેક્સ્ટ સ્લાઇડમાં લઈ જઈએ. હવે આમાં સમ કરીએ, પાવર બંનેનો સેમ છે, સો this implies sigma k is equal to 0 to infinity k + 1 a k + 1 minus a k into bracket x raised to power k, this is equal to 0, right. એનો મતલબ એ થયો, નાઉ ધીસ ઇઝ ઇક્વલ ટુ 0 + 0x + 0x² એન્ડ સો ઓન. એટલે આ બંને સાઈડના કોઓપ્શન્ટ આપણે કમ્પેર કરીએ તો કોન્સ્ટન્ટ ટર્મ હશે કે કોઈ બી ટર્મ હશે, એના કોઓપ્શન્ટ કમ્પેર કરીએ તો આપણને આવું મળશે કે k + 1 into a k + 1 minus a k, this is equal to 0, right. This is known as a recurrence relation. Relation of coefficient. જે સહગુણક છે એ સહગુણકોનું આ આપણને એક રિલેશન મળે છે. સો this implies my a k + 1, this is equal to a k upon k + 1. ઓકે, આ k + 1 ને આ બાજુ લઈ જાઓ, માઇનસ a k ને ડિવાઈડ બાય ધીસ, તો આ આપણને મળશે. હવે આ રિકરન્સ રિલેશન ઉપરમાં આપણે k ની વેલ્યુ જુદી જુદી લેતા જઈએ. So let us consider this is equation number 2, right. So take k is equal to 0 in 2, right. So if I take k is equal to 0 in 2, then my a1 is equal to a0 upon 1, right. Now take k is equal to 1 in 2, so my a2 is equal to a1 upon 2, right. Now a1 is equal to a0, so this is equal to a0 upon 2 into 1, right. Now take k is equal to 2 in 2, my a3 is equal to a2 upon 3, right. So this is equal to, now a2 is equal to a0 by 2 into 1, so this is a0 upon 3 into 2 into 1. Now take k is equal to 3 in 2, my a4 is equal to a3 upon 4. So now a3 is equal to this, so this is a0 upon 4 into 3 into 2 into 1, right, and so on. So now let us rewrite this thing. This is my a0, this is equal to a0 divided by 2 factorial, this is equal to a0 divided by 3 factorial, this is equal to a0 divided by 4 factorial. So we get this relation between a0, a1, a2 and a3, right. Now put this relation in the solution. મારું જે સોલ્યુશન હતું એ આપણે આવું ધાર્યું હતું કે y is equal to sigma k is equal to 0 to infinity a k x raised to power k. That was my solution. So y is equal to a0 plus a1 x plus a2 x square plus a3 x cube plus a4 x square x raised to power 4 and so on. So this is equal to a0 plus what was a1? So it is a0 upon 1 factorial x plus a2 was my a0 upon 2 factorial x square plus a3 was a0 upon 3 factorial x cube plus and so on. Now if I take this a0 common, then a0 into bracket 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So y is equal to this is required power series solution of differential equation dy by dx minus y is equal to 0. So this is the power series solution. Now here see the order of આ differential equation નો order કેટલો છે 1. તો અહીંયા arbitrary constants આપણને કેટલો મળે 1. તો આ solution થશે power series solution. આપણે first order નું power series solution જોયું. હવે આપણે next જોઈએ. So let us consider solve by power series method. Solve by power series method d square y by dx square plus y equal to 0. Okay. So solve our differential equation નું solution find કરીએ by power series method. Okay. Solution here y double dash plus y equal to 0. This is let us say equation number 1. Now solve this by power series method. So here compare this with y double dash plus p of x y dash plus q of x y equal to 0. So this implies my p of x equal to 0 and q of x is equal to 1. Both are analytic function at x is equal to 0. Okay. Therefore 0 is an ordinary point for this differential equation. So we consider y is equal to sigma k is equal to 0 to infinity a k x raised to power k, that is equal to a0 plus a1 x plus a2 x square and so on is solution. Now our aim is to find out, now our aim is to find out the relation, recurrence relation between the coefficient a0, a1, a2, a3 and so on. Okay. So let us find out that relations. My y is equal to sigma k is equal to 0 to infinity a k x raised to power k. So my y dash is equal to sigma k is equal to 0 to infinity k into ak x raised to k minus 1, right, and y double dash is equal to sigma k is equal to, here k is equal to 1 to, here k is equal to 2 to infinity k into k minus 1 ak x raised to k minus 2, right. Now, put this value in y double dash plus y equal to 0, right. So, this implies sigma k is equal to 2 to infinity k into k minus 1 ak x raised to k minus 2 plus sigma k is equal to 0 to infinity ak x raised to power k, this is equal to 0, right. Now, here અહીંયા આપણે change index in first term. આમાં ફર્સ્ટ ટર્મમાં આપણે ચેન્જ ઇન્ડેક્સ કરીએ. અહીંયા પાવર છે x રેઝ ટુ k માઇનસ 1, તો અહીંયા મારે પાવર જોઈએ છે x રેઝ ટુ પાવર k. સો change the index in first things. So we replace k minus 2 is equal to k. Okay, we replace k minus 2 is equal to k, right. So if I take k is equal to 2, so my new k will be k start from k is equal to 0 to infinity. Now k will be k plus 2 here, this k minus 1 will be k plus 1, because if I take k minus 1, so take 1 on this side, so this k minus 1 is equal to k plus 1 ak, so my k is equal to k plus 2, right, and here x raised to power k plus sigma k is equal to 0 to infinity ak x raised to power k, this is equal to 0, right. So this is my identity equations. Let us copy this one. Let's add these two things. So this implies sigma k is equal to 0 to infinity k plus 2 into k plus 1 into a k plus 2 plus a k into x raised to power k, this is equal to 0, right. Now 0 means what? This is 0 plus 0x plus 0x square and so on. So all the coefficient of this power series will be 0. તો આ પાવર સિરીઝના બધા જ કોઓપ્શન શું થશે? 0. એનો મતલબ થશે કે k plus 2 into k plus 1 into ak plus 2 plus ak is equal to 0. So from this one ak plus 2, this is equal to minus ak upon k plus 2 into k plus 1, right. This is my equation number 2 and this is my recurrence relation. Okay. So with help of this recurrence relation we will find આપણે a0 a1 a2 a3 એ બધાના relation find કરીશું, right. So take k is equal to 0 in 2, right. So if I take k is equal to 0 in 2, so my a2 is equal to minus a0 upon, take k is equal to 0, so 2 into 1, right. So a2 is equal to a0 into 2 into 1. Take k is equal to 1 in 2, right. So k is equal to 1 in 2, so my a3 is equal to minus a1 upon this k is equal to 1, so 3 into 2, right. Okay. Now take k is equal to 2 into, so my A4 is equal to minus A2 upon k is equal to 2. So 4 into 3, right. Now A2 is equal to A0 minus A0 by 2. So this is equal to A0 upon 4 into 3 into 2 into 1. So this is equal to A0 upon 4 factorial. Okay. Now take k is equal to 3 into, so I got A5 is equal to minus A3 upon k is equal to 3. So this is 5 into 4. Now A3 is equal to minus A1 upon 3 into 2. So this will be A1 upon 4 into 5 into 3 into 2 into 1. So this is A1 upon 5 factorial and so on. Okay. So now my solution will be y is equal to A0 plus A1x plus A2x square plus A3x cube plus A4x raised to power 4 plus A5x raised to power 5 and so on. Okay. So put all this value in this equation. So y is equal to A0 plus A1x. Okay. Now A2 is equal to A0 upon 2 factorial. So minus A0 upon 2 factorial into x square. A3 is equal to minus A1 upon 3 factorial, right. So minus A1 upon 3 factorial x cube. A4 is equal to plus A0 upon 4 factorial and A5 is equal to A1 upon 5 factorial into x raised to power 5, right. So all these coefficient is આ બધા જ coefficient એમાં મળે A0 A1 A0 A1 ની અંદર. તો આની અંદરથી આપણે A0 વાળા ટર્મ અને A1 વાળા ટર્મ અલગ કરીએ. So A0 into bracket 1 minus x square by 2 factorial plus next term શું આવશે x raised to power 4 by 4 factorial and so on minus and so on plus A1 into x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial minus and so on, right. So this is power series solution of y double dash minus plus y equal to 0, right. Now next example, find the power series solution of d square y by dx square plus xy equal to 0. Let us solve this solution. D square y by dx square plus xy equal to 0, right. So here compare with we can write this is y and y double dash plus xy equal to 0 લખી શકીએ. હવે આને કમ્પેર કરીએ આની સાથે કે y double dash plus p of xy dash plus q of xy equal to 0, right. તો આના ઉપરથી આપણને p of x is equal to શું મળે x and sorry p of x is equal to 0, p of x is equal to 0 and q of x is equal to x and both are analytic at x is equal to 0 and therefore x is equal to 0 is an ordinary point. Okay, so here we consider that x is equal to 0 is an ordinary point. So we will take y is equal to sigma k is equal to 0 to infinity a k x raised to the power k, that is equal to a 0 plus a 1 x plus a 2 x square plus a 3 x cube and so on. Let us say this is 2 is required solution, right. So from this one I will get y dash is equal to sigma k is equal to 1 to infinity a k into 1 minute k into a k x raised to the power k minus 1, right, and y double dash is equal to sigma k is equal to 2 to infinity k into k minus 1 a k x raised to power k minus 2, right. Now put this value in 1. Okay. So put all this value in 1. So we get sigma k is equal to 2 to infinity k into k minus 1 a k x raised to k minus 2, right, plus x into sigma k is equal to 0 to infinity a k x raised to the power k, this is equal to 0. Let me check, this is y double dash plus x y, right. So this is y double dash plus x and this is my y. Okay. Now here the power of x is equal to x raised to power k, here power of x is x raised to power minus k2, right. So this is equal to sigma k is equal to 2 to infinity k into k minus 1 a k x raised to k minus 2 plus take this x on this side. So sigma k is equal to 0 to infinity a k x raised to k plus 1, this is equal to 0, right. So here power is different. So to make the same power, change the index of this one. So change index in first term માં આપણે index change કરીએ, right. So what index, અહીંયા index શું છે, power શું છે, k plus 1, તો અહીંયા હું power શું લઈશ, k plus 1. okay. So take k minus 2 is equal to k plus 1 in first term. Okay, that k minus 2 is equal to k plus 1. Now if I take k is equal to 2 here, right, so k plus 1 is equal to 0, so k is equal to minus 1, right. So this will start from sigma k is equal to minus 1 to infinity. Now what is k here, so k is equal to k plus 3, so this is k plus 3, right, k minus 1, so 1 on this side, so this will be k plus 2, right. Now k is equal to k plus 3, right, and x raised to the power k plus 1, okay, plus sigma k is equal to 0 to infinity a k x raised to power k plus 1, this is equal to 0. okay students, આ સ્ટેપ બહુ જ ઇમ્પોર્ટન્ટ, ધ્યાન રાખો. અહીંયા પાવર શું હતો, k minus 1, રાઈટ. તો અહીંયા k minus 1 ની જગ્યાએ મારે શું જોઈએ છે, k minus 2 ની જગ્યાએ k plus 1. સો આઈ ચેન્જ ધ ઇન્ડેક્સ, આની ઇન્ડેક્સ ચેન્જ કરી k minus 2 ની જગ્યાએ k plus 1 લખ્યા. તો અહીંયા k is equal to સ્ટાર્ટ થશે, અહીંયા k is equal to 2 હતા. So if I take k is equal to 2 here, this is 0. So new k is minus 1. So here k is equal to minus 1, 2 and so on. Now here see, here it is, here શું છે k minus 1 અને અહીંયા શું છે કે ઇક્વલ ટુ 0. તો આનું એક ફર્સ્ટ સ્ટેપ આપણે અલગથી લખી દઈએ. સો ધીસ ઇમ્પ્લાઇઝ ટેક k ઇઝ ઇક્વલ ટુ -1. સો હું k ઇઝ ઇક્વલ ટુ -1 અહીંયા લઉં. સો ધીસ વિલ બી 2. આ શું થશે 1. k ઇઝ ઇક્વલ ટુ -1. સો a2 k ઇઝ ઇક્વલ ટુ -1. સો x રેઝ ટુ પાવર 0. રાઈટ. પ્લસ સિગ્મા k is equal to 0 to infinity k plus 3 into k plus 2 into a k plus 3 x is to k plus 1 plus sigma k is equal to 0 to infinity a k x is to k plus 1. This is equal to 0. Right. So from this one, this 2a2 into x raised to power 0 plus sigma. Now we can add these two things. So k is equal to 0 to infinity k plus 3 k plus 2 a k plus 3 plus a k into x raised to power k plus 1. This is equal to 0. Let us copy this one for next slide. Now here this 0 plus 0x plus 0x square and so on, right. So all the coefficient is 0. So from this one we get 2a2 equal to 0. Okay, this implies a2 is equal to 0. This is my first conclusion. આ મારું પહેલું conclusion છે કે a2 is equal to 0. Now all this coefficient is also 0. આ પણ coefficient બધા 0 થશે. So k plus 3 into k plus 2 a k plus 3 plus a k, this is also 0. So from this one we get the આમાંથી આપણને recurrence relation મળશે. K plus 3 is equal to a k upon k plus 3 into k plus 2, right. This is say equation number 3, recurrence relation. Okay. Now અહીંયા આપણે start કરીએ. So take k is equal to 0, right, in this one. So a3 is equal to a0 upon 3 into 2, right. Now take k is equal to 1. So a4 is equal to a1 upon k is equal to 1. So this is 4 into 3, right. Now take k is equal to 2, a5, this is equal to a2 upon take k is equal to 2, so 5 into 3, right. Take k is equal to 3, so a6 is equal to a3 upon k is equal to 3, so 6 into 5, 6 into 5, right. So now a3, so a3 is equal to a0 into 3 into 2, so this is equal to a0 upon 6 into 5 into 3 into 2. Okay. Now see a2 is equal to 0, so a5 is equal to 0, right. Now take k is equal to 4 in 3. So if I take k is equal to 4 in 3, so this a7 is equal to a4 upon k is equal to 4. So this will be 7 into 6, right. Now a4 is equal to a1 upon 4 into 3. So this is equal to a1 upon 7 into 6 into 4 into 3 and so on. Okay. So, let us put all this value in this equation. Y is equal to a0 plus a1x plus a2x square plus a3x cube plus a4 x raised to power 4 plus a5 x raised to power 5 plus a6 x raised to power 6 plus a7 x raised to power 7. So, this is equal to a0. So, a0 is a0 plus a1. So, a1x plus a2, a2 is 0 x square, right, plus a3. So, a3 is equal to a0 upon 3 into 2 x cube plus a4. So, a4 is equal to a1 upon 4 into 3 x raised to power 4 plus a5. So, a5 again 0. So, 0 into x raised to power 5. a6, a6 is equal to a0 upon 6 into 5 into 3 into 2, right, into x raised to power 6 plus a7. a7 is a1 upon 7 into 6 into 4 into 3 into x raised to power 7. Okay. So, now from this one my y is equal to, so here all these terms is come, આ બધા જ term જે છે એ a0 અને a1 માં આવે છે. તો હું આમાંથી a0 કોમન લઈ લઉં તો મને શું મળશે 1 પ્લસ x cube upon 3 into 2 plus x raised to 6 upon 6 into 5 into 3 into 2 and so on. અને જો a1 કોમન લઈએ so a1 into bracket x plus x raised to power 4 divided by 4 into 3 plus x raised to 7 divided by 7 into 6 into 4 into 3 and so on. So, this is the power series solution of the differential equation y double dash plus xy equal to 0, right. Now, solve y double dash minus y dash equal to 0 by power series method. Okay. So, solution, first of all we will compare with this y double dash plus p of xy dash plus q of xy equal to 0. So, here my p of x is equal to minus 1 and q of x is equal to 0, right. Both are analytic at x is equal to 0, right. So, 0 is an ordinary point. Okay. So, if 0 is an ordinary point, so we will consider our આપણે consider કરીશું solution y is equal to sigma k is equal to 0 to infinity a k x raised to power k is the solution. So, this is equal to a0 plus a1x plus a2x square plus a3x cube plus a4x raised to power 4 and so on, right. Okay. So, let us say this equation number 1. તો અહીંયા 0 ordinary point છે એટલે y is equal to sigma k is equal to 0 to infinity a k x raised to power k લઈશું. This is equal to this. So, y dash is equal to sigma k is equal to 1 to infinity k into a k x raised to power k minus 1 and ફરીથી આનું ડેરિવેટિવ કરીએ તો y ડબલ ડેશ ઇઝ ઇક્વલ ટુ સિગ્મા k is equal to 2 to infinity k into k minus 1 a k x raised to k minus 2, right. આ બંને વેલ્યુ આપણે 1 માં મૂકીએ. સો પુટ this value in 1. okay, so 1 મારું છે y double dash minus y dash equal to 0. so this implies sigma k is equal to 2 to infinity k into k minus 1 ak x raised to k minus 2 minus sigma k is equal to 1 to infinity k into ak x raised to k minus 1, this is equal to 0, right. So let us take this on next page. Our next step is to change the index. okay, so how to change the index of this one? So let us change in both and start with x raised to power k. so change index. okay, so in first term take k minus 2, that is equal to k, right. In second term take k minus 1 equal to k, right. So this implies sigma. Now if I take k is equal to 2, so my new k will start from k is equal to 0 to infinity. Here k is k plus 2, so this is k plus 2, this one is k plus 1, this ak is a k plus 2, here x raised to power k, right, minus in second term I take k minus 1 is equal to k. So if I take k minus 1 is equal to k, k is equal to 1, so this k is 0. So k is equal to 0 to infinity, here it is k plus 1 a, here my k index is changed, k plus 1 x raised to power k, this is equal to 0, right. So here if I take k is equal to 0, I will get constant term, here I will get k is equal to 0, I will get constant term. okay, so from this one sigma k is equal to 0 to infinity k plus 2 into k plus 1 a k plus 2, right, minus k plus 1 into a k plus 1 and x raised to power k, this is equal to 0, right. So all these coefficients is equal to 0. So this implies we get k plus 2 into k plus 1 a k plus 2 minus k plus 1 into a k plus 1, this is equal to 0. okay. So from this we get a k plus 2, this is equal to a k plus 1 divided by k plus 2. okay. Here k is not equal to minus 1 because we cancel that things. okay. So this is my recurrence relation. okay. So take this recurrence relation in next page. okay. So this is my recurrence relation. So let us say this is 3, this one is 3. okay. Now take k is equal to 0 in 3, right. So if I take k is equal to 0, so my a2 is equal to a1 divided by 2, right. Take k is equal to 1 in 3, so my a3 is equal to a2 divided by 3, right. Take k is equal to 2 in 3, So, my A4 is equal to A3 divided by 4. Take k is equal to 3 in 3. So, my A5 is equal to A4 divided by A5 divided by 5. Okay. Now, A2 is in terms of A1. So, this is equal to A1 upon 3 into 2, right. Now, A3 is equal to A1 upon 4 into 3 into 2. Now, A4 is equal to A1 upon 5 into 3, sorry 5 into 4 into 3 into 2. So, this is equal to A1 upon 2 factorial, this is A1 upon 3 factorial, this is A1 upon 4 factorial, this is A1 upon 5 factorial and so on. Okay. Now, put all this value in this equation, આ બધી જ વેલ્યુ આપણે આમાં મૂકીએ A0 plus A1x plus A2x square plus A3x cube plus A4x raised to power 4 plus A5x raised to power 5 and so on. So, y is equal to A0 plus A1x plus A1 upon 2 factorial x square plus A1 upon 3 factorial x cube plus A1 upon 4 factorial x raised to power 4 plus A1 upon 5 factorial into x raised to power 5 and so on. So, this is equal to A0 plus I can take A1 common from all these terms. So, this is x plus x square upon 2 factorial plus x cube upon 3 factorial plus x raised to 4 upon 4 factorial and so on is required power solution of y double dash minus y equal to 0. Solve dy by dx minus 2xy equal to 0 by power series method. Okay, so this is first order differential equation. So, only one first order differential equation છે એટલે આમાં એક જ arbitrary constant આવશે. Okay. Solution, compare with y double dash plus p of x y dash plus q of x y equal to 0, right. So, here my p of x is equal to 1, q of x is equal to minus 2x, both are analytic at x is equal to 0. Therefore, x is equal to 0 is an ordinary point. So, we consider the solution is of this form: y is equal to k is equal to 0 to infinity a k x raised to power k, that is equal to a0 plus a1x plus a2x square plus a3x cube and so on, right. Say this is 2, this is my equation number 1, right. So, my y dash is equal to y dash or dy by dx. So, that is equal to sigma k is equal to 1 to infinity k into a k x raised to k minus 1, right. Now, put this value, put this value in 1. Okay. So, if I put this value in 1, dy by dx minus 2xy equal to 0. So, this implies sigma k is equal to 1 to infinity k into a k x raised to k minus 1 minus 2x sigma k is equal to 0 to infinity a k x raised to power k, this is equal to 0, right. So, this implies sigma k is equal to 1 to infinity k into a k x raised to k minus 1 minus 2 into sigma k is equal to 0 to infinity a k x raised to power k plus 1 equal to 0. I multiply with this x. So, here it is k plus 1. Okay. Now, change the index. Okay. So, change the index. Okay. So, in first term, take k minus 1 is equal to k, okay. And in second term, take k plus 1, this is equal to k, right. So, my first term, this will be sigma. So, if I take k is equal to 1, so this will be k is equal to 0 to infinity. So, here it is k plus 1 into a k plus 1 x raised to power k minus 2 into sigma. In second term, if I take k is equal to this, then here it is k is equal to minus 1 to infinity, okay, k plus 1. So, k is equal to k minus 1 a k minus 1 x raised to power k, this is equal to 0. So, here it will be, if I take k plus 1 is equal to k is equal to 0, then k is equal to 1. So, here start from k is equal to 1 to infinity, right. So, if I take k is equal to 0 in first term, okay. So, this will be 1 into a1, right, and k is equal to 0. So, x raised to power 0 plus sigma k is equal to 1 to infinity k plus 1 into a k plus 1 x raised to power k minus 2 sigma k is equal to 1 to infinity a k minus 1 x raised to power k, this is equal to 0. So, from this one a1 plus sigma k is equal to 1 to infinity k plus 1 into a k plus 1 minus 2 a k minus 1, right, into x raised to the power k, this is equal to 0. Now, compare the coefficient on both sides. So, I will get a1 equal to 0 and k plus 1 into a k plus 1 minus 2 a k minus 1, this is equal to 0. So, from this one a k plus 1, this is equal to 2 a k minus 1 upon k plus 1. Okay. So, this is my recurrence relation. Okay. So, let us say this is 3. So, take k is equal to 0 in 3. Okay. So, my the k is equal to 1 in 3. So, a2 is equal to k is equal to 1 is 2 a0 divided by 1. Now, take k is equal to 2. So, a3 is equal to 2, a is equal to 2. So, a2 a1 upon 3, right. Now, a1 is equal to 0. So, this is equal to 0. Now, take k is equal to 3. So, a4 is equal to 2 a2 upon 4, right. So, this is equal to 2. Now, a2 is equal to 2 a0 by 2. So, 2 upon 4 into 2 a0 by 1. right? So this is equal to a0 and so on. Okay, so છેલ્લા સ્ટેપ ઉપરથી આપણને આવું મળ્યું છે a1 is 0 and this recurrence relation. હવે આપણે જોઈએ જો હું k is equal to 1 લઈ લઉં 0 લઈએ સો સોરી 1 k is equal to 1 તો આપણને a2 is equal to શું મળશે 2 a0 divide by 1. હવે જો હું k is equal to 2 લઉં તો a3 is equal to 2 a1 upon 3, right? Now a1 is equal to 0, so a3 is equal to 0. Now take k is equal to 3, so a4 is equal to 2 a2 upon 4, right? Now a2 is equal to a0 by this, so 2 by 4 into 2 by 1 into a0, so this is equal to a0, right? Now k is equal to 4, so a5 this is equal to 2 a3 upon k is equal to 4, so this is 5, right? Now a3 is equal to 0, so this is equal to 0. Now take k is equal to 5, so a6 is equal to 2 a4 divided by 6, so this is 2 by 6. Now a4 is equal to a0, so this is 1 by 3 a0 and so on, right? So now my y is equal to a0 plus a1x plus a2x square plus a3x cube plus a4x raised to power 4 plus a5 x raised to power 5 plus a6 x raised to power 6. So this is equal to a0 plus 0x plus a2 is equal to 2 a0 x square plus a3 is 0 x cube plus a4 is a0 x raised to power 4 plus a5 is 0 x raised to power 5 plus a6 means 1 by 3 x raised to power 6 and so on. So this y is equal to a0, take constant 1 plus 2x square plus x raised to power 4 plus x raised to power 6 divided by 3 and so on is required solution of given differential equations. તો સ્ટુડન્ટ્સ આ લેક્ચરમાં આપણે હાઉ ટુ સોલ્વ પાવર સિરીઝ મેથડથી ડિફરન્શિયલ ઇક્વેશન કેવી રીતના સોલ્વ કરવું એ કોન્સ્ટન્ટ કોઓપ્શન્ટવાળા દાખલા જોઈએ. નેક્સ્ટ લેક્ચરમાં આપણે સેકન્ડ ઓર્ડરના સમ જોઈશું જેમાં કોઓપ્શન્ટ છે એ કોન્સ્ટન્ટ નહીં હોય. ઓકે, થેન્ક યુ.